Hey there, this is Dr. Bart. I wanted to go over some more examples of how to write functions that consume generic dictionaries. So very soon, when you get past these first couple lessons in this module, you're going to be working with records, which are much more sophisticated than just a generic dictionary. It adds some extra constraints onto it. But when you first start off, we're just working with very vanilla, regular old dictionaries. And when we write functions that manipulate a generic dictionary, there's a few things that I want you to consider. So let's start just by making some dictionaries, right? So if we say that we wanted to make a person, right? Person one, we'll give them a name, which, we could have Ada, could be a person, and an age, she'll be 2. And maybe since Ada is not just any old kind of person, she's a corgi, we'll say that she is breed corgi. We'll make a person 2. This one will still have a name. We'll say that this name is Ellie, and age is 44. And then for the last attribute is has job is true. So I've made 2 dictionaries so far, and they both have the name key, they both have an age key, but they have very different third keys, breed and has job. We'll also make a third dictionary representing a game. So a game can have a name, and we'll give the name Final Fantasy VII, a new game that just came out recently. We won't give it an age, we'll just give it a play length, and that will have 47 minutes. So 40 hours. So now we've got 3 dictionaries, person 1, person 2, game, and just for interests, we're going to have one more, which will represent, how about food in the fridge? So a hamburger that we have in the fridge. It won't have a name field. It will have an age field. It's been in there for 1 week, and we'll say that it has a calories, which is 400. So we should probably throw that hamburger out, but at the very least we have a dictionary representing it. Now, when we have these dictionaries, we can do some things with them. In particular, we could just get the entire dictionary. So I run down in the console, person 1, spits out the whole dictionary, all of its keys, name, age, and breed, and the values associated with them. A person here, the person 1, is more than just its name. It's more than just its age. It's more than just its breed. It's all of these things put together into one. And that's why dictionaries are great, is they allow us to combine data into one more complicated thing. And we can get it back out later. So if I ask for its name, I get Ada. If I ask for its age, I get 2, and so on and so on. We can also update that data. So if Ada has a birthday, we say we get her old age. Well, we'll start with assigning 3, and now person. I have to get the variable name right. Person 1's age is 3, and now person 1, Ada, has an age of 3. If you combine those 2 ideas of getting and setting, person 1 age plus 5, that takes the old value and updates it to now be 8. So we already can see that we have the ability to get and set data from our dictionaries. All right, so let's write a function that, given a dictionary, retrieves the age key. And it's important to note that this function won't work on the game dictionary. It can't work on the game dictionary. It only works on person 1 and person 2 and hamburger, because they all have an age. So if I define my getAge function as a function that consumes a dictionary, we don't know anything about that dictionary really. We know it has to have a name key, an age key. So we know its type is a generic dictionary, DICT, dictionary. We have a few choices for the name. Could be adict, just a generic dictionary. Could be sumdict, indicates a some generic dictionary. Could be sumdict with age, right? So now we're being very explicit that it has to be a dictionary that has an age key, or adict with age. Recognize that doesn't stop the user from calling the function with the wrong parameter name though. So let's go with addict with age just to be lengthy, and it produces a integer, right? All of our ages represent a integer value, so it will return an int. Okay. We don't know what it does. Let's leave that alone and instead jump down and write some unit tests. So I can assert equal that if I call getAge on person 1, that'll produce the value 2. If I assert equal on getAge for person 2, then that produces 44. If I assert equal on getAge game, it's an error. It doesn't matter what it returns because this code can't run. So I literally can't pass in game as a parameter, as we will shortly see. I'm going to leave it in just to demonstrate, and I'll put in none just because it doesn't matter. It's not going to work. We're going to have to delete that code. But it will work for hamburger. So when I pass in hamburger, we'll end up with the age of 1. Obviously, if we run it just now, it's not going to work anyway because we're not returning anything. So let's go and figure out how to implement getAge. Now, a lot of people get very confused around this point in time, and they think that they have to somehow have passed in age. And that doesn't work. That doesn't make sense if you think about it. This gets the age given a dictionary. It's given a dict. It's given a dictionary, and it returns the age. When you're given a dictionary, how do you access data in it? You use square brackets, right? So you pass in a key in between the square brackets. This one's supposed to retrieve the age. Okay, well, this function's supposed to return the age key associated with that dictionary, and that's what this line of code does. If I run it, we're going to get the error message I talked about before, right? Big old nasty traceback. If we follow the traceback, it says, hey, in line 20 of your program, you called assert equal getAge game none. And getAge game was a function, so I called it, and that's what this next line of code says is, okay, inside of getAge on line 16 of your program, you had this line of code return a dict age, and that produced a key error. It didn't work. In fact, I tried to find the key age in this dictionary that was associated with game, and it super wasn't there. It's very confused. It doesn't know what that game is. If we look over here on the side, Thonny tries to give us some extra help by spelling out the current local was the game dictionary, Final Fantasy VII, play length 40. It doesn't have a key called age, so it all kind of fits together why we're getting this trouble, right? Why we're getting this error. So let's get rid of that test case. It can't work. There's no value I can set for the return value that would fix it. I could do some code inside the getAge to handle that case, right? If I had an if statement, I could say, if you don't have an age key, then do something different. But that's not what the question wants me to do. We're assuming for now that the dictionary has an age key. And you see now my unit tests all pass. All the other ones work just fine. So let's do another interesting question. This one will consume a dictionary that has the keys highs and lows. So now we've got 2 keys that we're going to work with, 2 keys. All right, so let's start by making a dictionary. Highs and lows, right? This is talking about weather data. So weather 1 will have highs for the past week, essentially. So that there are 3 high days and 4 low days. And weather 2, maybe we've got a longer record now, 55 highs in the past few days and 7 lows. So we've got some representation here, some dictionaries that have these keys, highs and lows. I'm thinking it's weather data. Could be anything, right? Doesn't matter what it is. All we know with this is it's a function that will consume a dictionary and returns the sum of their highs and lows keys. If they have other keys, that doesn't matter. Maybe they got mediums. That's okay. Won't affect our function. Our function is going to be called combine data. We don't actually say create a function named combine. Just got to give it some kind of name. And it consumes a single dictionary. So once again, a dict. And produces the sum of the values associated with the highs and lows. We'll assume those to be integers. It's important to understand here, you're not passing in highs, comma, lows. You're passing in a dict. The dict has highs and lows inside of it, but this function only consumes 1 parameter. It's a little weird, but that's how it works. If we go back to our assert equal, then we can say that when we combine weather1, it's 3 plus 4, 7. If we assert equal on combine of weather2, then we get 55 plus 7, which is 62, I think. Now, when we have this code over here, we will see that we are failing our unit tests, and that's okay. Now we just got to go write the body. Once again, we're taking a dict and accessing the highs this time, and we need to combine that with the lows. So we have highs and low values. We got the values associated with the keys inside the dictionary. The goal is to sum them together. Just because it says sum doesn't mean we need the sum pattern. There's only two values, highs and lows. So just add them together. If we didn't know how many there were, if they were in a list, then we would need a sum pattern. But if we're just adding together two values, we just use a plus. And we can just return that value. Let's see if I got my math right. Success. So you see that we're able to pass around these more complicated objects that have, these more complicated things, these dictionaries that have keys, and we can use those keys to get values. A lot of people are starting to make mistakes where they try and they try and use weather1 inside, oh God, that's how you spell it, weather1 inside that function, but you really shouldn't. The goal is to reference the parameter, a dict, each time, and that way it ties back to the combine function that we had, the parameter that we passed into the combine function. And it'll work for weather1, weather2, whatever we pass in there. Now, one last thing I want to highlight about dictionaries, and this is easy to kind of lose track of, is that they're mutable as a data structure, like a list, but not like a string. And unlike a list, we don't encourage you to make unique copies of them, to make new copies, new versions of them. You make an empty list and you fill it up with the old attributes, the old elements. Instead, we're asking you to modify them. So let's say I had a function that was increase highs, right? That would consume one of these dictionaries and it doesn't produce anything. If it did something like this, where it took a dict and changed highs by adding to it, right? I'm allowed to write that, plus 1. When I call this function, if I spell it correctly, heights, not highs. When I call this function, it's really important to understand what happens with it. So I'm going to take it, I'm going to call increase heights. First, let's check out weather1. Its old value was highs 3, lows 4. When I call increase heights, unlike the way we learned about simple variables, primitive types that are immutable, like integers and strings, when I pass in weather1, it doesn't return anything. But if we go check out weather1's values, it's changed. When we change a dictionary's values, the keys associated with the values, we are modifying that original dictionary, right? This is tough to keep track of. It's a whole source of new errors are possible because if we keep reusing those variables in later unit tests, we have to keep track of what changed about them. This is powerful. It's super powerful, but it's very dangerous in its own way. So every time I call increase heights on weather1, it's changing that value. I have to be very careful with that.